Hello, good to have everybody back. Welcome to another video and another joke. Woohoo! What do you call a song about a tortilla? A rap. Chicka chicka wow wow. Okay, let's get into it. So today we are talking about the reverse chain rule. Okay, it's like the chain rule, but in reverse. Okay, now it looks a little bit like this. Probably need to get that down. But I do want to make a couple notes here, or a couple kind of distinctions. So the first things first is we have this kind of bracket to the power of n, but then we also have this f dash x, okay? So that means is if we have our function to some sort of power, and then we have our derivative out the front, the derivative of that bracket out the front, then it's just going to become our function raise 1 to the power n plus 1 divided by the new power plus c. Okay, now we mainly use this in integrating products that have brackets and powers. That's probably where we see it the most. And we kind of, with the reverse chain rule, it's like we use differentiation to help us to integrate. So if we start with something like this, these are how the questions may often pan out. They'll start with differentiate, and then they'll say, hence find a primitive. So let's try to work with this first. So this first one here, we want to differentiate y equals x cubed plus 5 to the power of 6. So your y dash using your chain rule is the 6 comes down to the front. Your bracket stays the same. You take away 1 from the power, so now it's to the power of 5. And then what you do is you multiply it by the differentiation of the bracket. So the differentiation of x cubed is 3x squared. And just cleaning things up a little bit, that gives me 18x squared bracket x cubed plus 5 to the power of 5. Okay, now what they'll say here is hence find the primitive of, and primitive is just another fancy way to say find the primitive of 18x squared x cubed plus 5 to the power of 5 dx. Right, that's what it means to find the primitive. And in this case here, we can see that if we started here with our 18x squared, if we would integrate it, because we differentiate it this way, differentiate, so we'd integrate and would end up back at that. So we're going to go x to the 3 plus 5 to the power of 6, and then it'll be plus c. Yep. So we're just ending up back at the same place. So this is where it starts to get a little bit interesting or a little bit trickier is, what if they asked you not to find 18x squared, whatever, everything else? What if it was just 3x squared this time? So in essence, this one would just be x cubed plus 5 to the power of 6 plus c. But this time, if we went from 18, right, from 18x squared, that's what it would have been if we differentiated, but now we only have 3x squared up front. We're going to have to divide everything through by 6 in this case. So we're going to divide through by 6. And that would give you your answer there. All right. Now, let's say, for example, if it was instead of 18x squared, which is what it would have been if we differentiated it, what if it's just singular x squared? Well, then it would be x cubed plus 5 to the power of 6. And this time we're going to divide it by 18 and plus c. Okay. Now, this may have been a little bit simple and upfront because we kind of did the differentiation first. And we can kind of just adjust it from there. But let me show you what a question may look like if they don't kind of tell you. So we've got this integration of x cubed, x to the 4 plus 7, all to the power of 4. So the first things first is we're going to look at this bracket here, right? That to me is technically, that's going to be our fx, right? And so we're hoping that that there kind of ends up looking like our f dash x. So let's just look at our function first. So our function is we have x to the 4 plus 7. So I'm going to differentiate. So that's going to give me f dash x, and that's going to give me 4x cubed. Okay, so I'm going to keep that in mind. Now, if I was to continue on here, I know that it's going to look a little bit like this. Let me rewrite it a little bit. So I'm going to rewrite that as, it's the same thing as integrating x to the 4. Yeah, let's do that, shall we? My bad. What we're going to do here is we're going to change the form slightly. Okay, so we're going to we kind of want it to look like this, right? So 4x cubed, x to the 4 plus 7 to the 4 dx. Now, because I added in that extra 4, I'm going to have to take it out at the front. Okay, because now we know that this, I don't know if you can see, but this here becomes our fx to the power of, I guess, 4. And here becomes our f dash x, which is kind of what we had all the way up here in the beginning, right? We've got our, I just swapped the orders around, but you've got your function to a power, and then you've got your derivative of that function. And I've got that here, right? Because my derivative of x to the 4 plus 7 is just 4x cubed. And so now I've got it into this kind of form. I can see here that now it's just, okay, let's keep going with the blue. It's going to be a quarter of, and we know the integration should just be fx to the n plus 1 on n plus 1 plus c. Okay, so in other words, it's going to be our bracket, which is going to be x to the 4 plus 7. And instead of to the power of 4, I'm going to raise it to the power of 5. And I'm going to divide it by the new power of 5 plus c. All right, and just to clean it up again, I've got that 1/4 out the front, so I'm just going to go numerator with numerator, denominator with denominator, and that's going to leave me with x to the 4 plus 7 to the power of 5 all over 20 plus c. Okay, now let's do one more. Hopefully you're keeping track. Now, again, I'm going to write this as, let's see, I'm going to write fx equals, and I'm going to write this thing here, 1 plus x squared. And here, if I was to do, to the power of a half, right? So if I was to go, jokes, we're not going to worry about the power of the half yet. Let's just talk about 1 plus x squared. All right, so here, my f dash x would become 2x. And that is kind of the same power of x that we've got out here. So that means I can kind of work with it. So if I want to integrate this now, I'm going to rewrite it as this. It equals the integration of, and I want the 2x there, but because I only have a singular x in the first one, I'm going to have to divide it by 2 or times it by half on the outside. Right, and then I'm going to have this 1 plus x squared to the power of half dx, and that's going to give us that. And so now when we integrate it, it's just going to become our normal integration. It's going to be a half out the side of, we're going to get 1 plus x squared, and I'm going to raise the power by 1, which is going to be 3 on 2. And I'm going to divide by the new power, which is 3 on 2. And then that's it, plus c. And again, all I'm doing here is just rearranging. I know that that 2 is going to jump out the top, so it's going to be a half times 2 bracket 1 plus x squared to the 3 on 2 all over 3. And that's nice because that will cancel out, and it's going to leave me with 1 plus x squared to the power of 3 on 2 all over 3 plus c. Don't forget your plus c's, guys. Don't forget your plus c, kids. Vitamin C. And so that would be how we use the reverse chain rule. So in summary, all you're really trying to do is you're trying to get this to look in the form of f dash x, fx to the power of n. That's what you're trying to get. Once you kind of get it into that form and you kind of adjust it by taking out whatever you need, then you can integrate with almost your normal rules. Okay, hope that makes sense. And I'll catch you guys later. All right, bye-bye.